Okay, everyone, this is part 2 of today's video. We just finished reduction. Do you remember reduction? And then here is the reaction equation. And I want you to practice writing some balanced chemical equation for reduction of aldehyde or ketone, or even carboxylic acid. So I will give you a free example. For example, the first one is H3COOH. If you use this one, you have to use lithium aluminum hydride, but you can't use NaBH4 because there is no reaction. It will go back all the way to primary alcohol. Okay, as I said, when you have to balance the equation, you first use water to balance the number of oxygen. There are 2 oxygen on the left hand side. Can you see that? 2 oxygen, but 1 oxygen. So we are going to add 1 H2O, right? And then later on, you will find that there are 3 hydrogen, but only 1 hydrogen here. So you need to add 2 H bracket. Now this is how we present a balanced chemical equation regarding reduction of either carboxylic acid or carbonyl compound. Okay. Now then we try 2 more. For example, if you have an aldehyde, so this time you can use both of them. Doesn't matter because it's not carboxylic acid. Then it will go back all the way to primary alcohol. Same as before, we use water to balance oxygen, right? But when you look at both sides, they both have 1 oxygen only. So the only thing you have to balance is hydrogen. Here, 1 hydrogen. Here, you have 3 hydrogen. So you add 2H. Any questions? The last one, let us try a ketone, a reduction of a ketone. For example, a propanol. Propanol is a secondary alcohol. When it is reduced, it will go back to secondary alcohol. Okay, same as before, you can check the number of oxygen is 1. So you don't have to use any water molecules. However, when you look at the number of hydrogen, here, 3 hydrogen, 3, 4, 5. So you need to add 2 hydrogen atom here, okay? Now this is the first reaction, reduction of aldehyde and ketone. Right now, I will introduce the second one, nucleophilic addition with HCN. Nucleophilic addition is the mechanism. Here is the last mechanism that you have to know in your syllabus. You have to draw the diagram to show how the electrons are moving, which one attacks which one, so that the product is formed. Okay, so now before that, we have to know the reactants imported. We use HCN, the reactant is propanol. HCN normally is prepared in situ. Okay, as I told you, in situ means you're going to heat a salt together with, for example, an acid, then it will generate HCN. This one will generate NaCN. This one will generate HCN together with NaHSO4. Very similar to the to the topic that we learned in halogen. So now, for example, if you have propanol plus, okay, now I try to use different color to show you what's going on. CN, okay, and then what's going on will be, listen up. Of course, look at the functional group C. Now the double bond of CO, C double bond O, will become single bond, and then this O will be bonding with the H from HCN, okay, and then the CN group will be bonded to this C, and the H remain unchanged. So can you see that? So how can we name this? Since there are 2 functional groups, and this one has a higher priority, so this is the P first. So right now it's carbon 1, 2, 3, 4, right? So it's called 2 hydroxyl 1, 2, 3, 4. Butyl nitrile 2-hydroxy butyl nitrile. Okay? 好啦，now let me show you the mechanism of the reaction. This is very important, very important. It's called nucleophilic addition reaction. Now there are 2 steps. For step 1, I use this to show you. Okay, the methanol. Now since you know this bond, the CO bond is polar, positive, negative. Okay, so now when HCN is put in water, since it is a weak acid, it will provide H plus and Cn minus as well. Okay, so you have Cn minus, and there is a lone pair. So the first step is this lone pair will attack this C, and one of the bond will be broken. Okay, I repeat once again, the lone pair of Cn minus the cyanide ion will attack the partial positive charge of carbon, and then the C double bond O, one of the bond is broken. So you will get this one. Okay, you will get this one. And then the step 2 is very easy, which is this intermediate. Capture a hydrogen ion in water to form the portet. Okay, so that's why we get the portet. Now you have to know how to draw this mechanism. Practice drawing this mechanism. Okay, so this is nucleophilic addition reaction. Nucleophilic means that this is a nucleophile. Can you see nucleophile? It attacks the positive carbon. Addition means when you see that basically these two, they combine together without any elimination of byproducts. So it is addition, nucleophilic addition. Okay, now when you compare the reactant and product, you will find that originally there are 1, 2, 3, 3 carbon, right? But in the end it is 1, 2, 3, 4, 4 carbons. So this is a very important reaction in organic synthesis because you can lengthen the main chain of the carbon compound. Okay, now looks that a carbon atom has been added to the propanol by the addition of a nitrile group. Okay, so it's very important in synthetic chemistry. That increases the length. Okay. Oh, now if you remember what I told you in the previous chapter, the CN group can be hydrolyzed in acidic medium to become COOH. So we see this again, hydrolysis. Okay. So basically, it's the CN group together with acid and water. It will turn to COOH together with NH4 plus. Okay. So basically, you have to pay attention on this one and this one. Very important. This is a very important reaction in interconversion of organic compounds. Okay. And then this one is also very important. If the CN group is reduced with sodium using sodium ethanol or lithium aluminum hydride. Okay, there are several in dry ether. Okay, several reducing agents you can use, sodium and ethanol or lithium aluminum hydride. Then you can turn it to CH2 and H2. For example, if you have something like that, okay, after reduction, it will become CH2, CH2NH2, remember. So look at here, this group, become this group, okay? So don't mix the carbon at the front, okay? Let me see the time. Okay, any questions so far? Now, then, students, you can see there is a past paper here, a past paper question. I want you to try this tonight, and then I will get back to you tomorrow or on Monday to check the answers with you. Then we will continue with the following parts, okay? If you haven't submitted your paper 2 to me, remember to do it by tonight, okay?